No, we'll take a different approach. It's great being here, and so kind of start off with it. Our project is a little bit different. We have a little bit different approach. Sometimes when we look at water, I kind of like to look at things other than just in my backyard. So if we look at the worldwide perspective on how we deal with water, it kind of gives us a little bit different perspective. If you look at the deal, it shows there's a lot of stress on all the aquifers of use of water. If you look at how much the world and the water has declined since 2002, it's quite interesting. And the graph that shows that's marked out, that's the Ogallala Aquifer. So I'll preach to the choir for just a second. If we look, the Ogallala Aquifer covers about 174,000 square miles across 8 states. And over 95% of the water that is pumped is used for irrigation. We're on the southern Howe Plains, and it's like it is here. It's a very important part in our agriculture in the state of Texas. But if we look at the pre-development changes, water level changes since 1950, when the time it began to start pumping from it, we show that Hale and Floyd counties, where the project is at, we have had a lot of decline in our water. The percent of saturated thickness is about 50% gone. So there's been a lot of push to ways to look at water conservation. The water project that we're involved with it covers about 98,000 acres, but there's only about 6,000 acres that we're actually doing data research on. And if you look at from the data from the water district, it shows that since the beginning that the water project has started, we have lost about 25% of our saturated thickness. We have worked very, very close with our High Plains Underground Water District, and what they have done is they have installed transducers into some irrigation wells that we can have real-time data of how much water is declining in each well. Not all of them, but we use just certain wells in certain areas. And so if you look at this, you can see how our water has gradually declined. And what's really interesting is the blue bars that shows the decline is the time that we're pumping in the summer times. It's pretty mind-boggling to show that we may have a 40-foot drawdown on our water during the summer months. If you see that over time, that water has declined. This is an abandoned well, and it shows that the same thing. They put a transducer in the well, and it may be half a mile or a mile from wells that are being pumped. And with that, really you show that there has also been a steady decline. So where are we going? What is the Texas Alliance for Water Conservation? In 2004, we had Senator Robert Duncan, a senator from Lubbock, had the idea, and what he did is he wrote the bill, Senate Bill 1053. It appropriated $6.2 million funded for 8 years for a project. His idea is that we have spent millions, if not billions of dollars of equipped dollars, and we're still running out of water. We haven't saved any. So that was his mindset. With that, we set it up through cooperators, and in 2012, it was supposed to end, and with very good management, we was able to extend the program just from the money that was appropriated for 2 more years. In 2014, when the state legislature met, we was able to renew this program for another 5 years. And one benefit is we was just getting to the point where we were starting to see a lot of trends and the things that we were looking at. The project is producer driven. And so I am the chairman of the producers. And so one reason that we do that is we don't want to have something come into here to be a snake oil, to be a quick fix. So we do look at that. The project of the development and the demographics to demonstrate new technologies and management tools that we can look at strategies on how we can use less water and with enhanced profitability. really the picture here is all the producers right now kind of scratching their head wondering what they're going to do with the farm program and what we're going to plant. But part of the objectives is to identify effective crop and irrigation systems and impact producer decision-making processes. Within the project, we have about 33 sites, 21 producers, with a total of about 6,000 acres of crops. We've got cotton monocultures, cotton and corn, grain sorghum and cotton, cotton and cattle, grass cattle, and then we have specialty crops such as sunflowers, grasses, seed millets, and that kind of things. The only thing I want to say here on this is I'm not going to go through each one of these, but the project does not dictate to the producer what crops to plant or when to plant them or how to plant them. The purpose of the project is a demonstration project. We're going to monitor whatever the producer is going to plant at that time. So as you can see, we'll take the example of cotton on the top line. The market directs and dictates what is going to be planted and how is it going to be planted. On each site, what we do is we monitor the rainfall, the temperature, how much water is applied through net irrigate, soil moisture with AquaSpy, CropSense, or AquaCheck. Each producer has a production input, has a notebook that we keep track of all the inputs. Plant and animal yields, those are included in the notebook. And then economic analysis. And Texas Tech does all the economic analysis and they collect all the data, except for the water. One of the things that we look at is from 2005 and 2013, kind of what this shows. I know it's kind of a little busy slide, but really what it shows is how much water each crop uses. And as you can see, in 2011, there's a pretty tall bar. Well, that was the beginning of the drought, and that really has made a big changes in how we do things. One of the things that we have found is through some of the analysis that Tech has done is that anytime a producer starts pumping more than 15 to 18 inches of water per acre, it comes to the point of past the point of diminishing returns. And so as you can see, 2011, 2012, there's been a lot of water pumped. Our irrigation methods that we're monitoring is sprinkler, furrow, subsurface drip, and dry land. We're always looking at new technology and trying to demonstrate those new technologies with the cooperation of some of the producers. One of the things we're going to be looking at this coming year is precision mobile drip irrigation. We're going to look at some of the variable rate irrigation. We have one producer who actually owns the company who has come to us and wants us to look at it and help monitor what's going on. We have capacitance probes. And we're not necessarily looking at one brand, we're looking at all capacitance probes. We're looking at the Smartfield data, which is developed right there in Lubbock, Texas from the USDA stress lab of Dr. James Mahan, who's using our RT thermometers. We're also looking at meters. From the very beginning of the project, we looked at all the various meters on how we monitored the wells and the pivots. And one of the things we found out is that all meters are not the same. We had a kind of a learning curve on which meters to use and which one's the most accurate. We also have an outreach with this program. We started having field walks, and what our purpose was to get producers to go look at the technologies and the things that we were doing and trying to help them train and educate. Because we feel like that it's a whole lot easier for a farmer to learn from another farmer than what it is to have somebody come out of research, of a small plot research that says, well, this is what you need to be doing. Because these are not small plots, these are whole farms. Some of the technology that we're demonstrating and comparing is a LIPA spray, PMDI, and the LIPA. Does anybody know what the difference between the LISA and the LIPA? LISA, or spray, is low energy precise spray application. PMDI is precision mobile drip irrigation, and the LIPA is low energy precise application. That has all changed because since the use of GPS and that kind of stuff, we can be very precise in how we farm. The idea behind this is we all farm in circles. If you've ever been in our part of the country, it's fairly flat, so we don't have very many variabilities. So we can farm in circles. We used to have to kind of furrow everything and use dikes. Now what we do is we rely on soil residues and no-till and that kind of stuff. So the difference between one and the other is broadcast spray is about 60-65% efficiency, and LEPA is about 90 to 95% efficiency as far as water applied. The Smartfield Technology, like what I said, is it determines a crop, an irrigation management or a trigger of an irrigation based upon the crop stress in the canopy. So we look for ways on the capacitance probes, and this is a field that we used in a drip, and how we manage that water in that drip is very important, because what happens to a lot of times with producers with drip, they don't ever see the water, so they turn it on, they kind of forget it, and they don't really manage it correctly. But with these probes, it gives you a chance to look at how much water is going out the bottom of the profile. Our land area is a Pullman clay loam. Most of the time it's about 24 to 28 to 30 inches deep. And anything below that, that water goes out the bottom of a caliche type subsoil base. And it's very hard for us to recoup that water that deep. So we have to manage the top 30 inches. Our outreach. This past January, we come up with a water college. We kind of changed the venue up, and we had it in Lubbock, Texas, and we had a very, very good success. We had probably 150 producers that actually showed up, and we covered all aspects of irrigation management and some of the things that we were working on. And next year, we're already planning for one for next year. We have field walks, and when we first started the field walks, we had a couple of crop consultants that was really interested in water management, and they was dealing with water management on their own producers that they were hired. So we hired them to help us to gather some of the data and try to educate other people in other areas. We're going to have some field walks in other counties other than just Hale and Floyd County. We also have developed a World Wide Web on www.TAWC-Solutions.org, which has several things that we have written into this web base. We have a resource allocator, which shows it's a planning aid tool for various crops and water scenarios, and it captures the change of the commodity prices, water availability, and production cost, and it's very, very simple to use. And to generate several options on which ways to maximize the net returns of our water per acre. Maybe not use the most water. It's not designed to see which is going to use the most water, but determine which one is going to maximize the returns for what water we do have. Texas A&M at one time had a PET network, and that was kind of dropped due to funding. So that come back to play that we felt like that we needed another PET network. We have developed, since then, has developed a program using the West Texas MESNet. There's only over 80 sites. Then what we do is you can just dial into the one that's closest to you. It's a web-based tool, very easy to use. It tells you when to apply water, how much water to apply, and how to achieve specific management goals. Whether you look at irrigating it, whether it's a 65% of ET or whether it's an 85 or 90% of ET. It's very, very easy to use, and it's very straightforward. Now let's look at yield and percent water demands. What we've seen on this is just one crop. One of the things that we did find is when we started monitoring the sites on how much water was being used, it was a real educational to all the producers, because we was in an area where we didn't really have to monitor our water. So how can we determine things without doing the monitoring or looking at how much water we used? As a producer, myself and other producers, when we started looking at how much water we used in a day, it was mind-boggling. But yet on the other side, we also knew that we had to learn ways to conserve the water, even though we did. Well, what we found out in the first several years is that a lot of producers were over-irrigating cotton at more than 100% of ET. And we started showing trends, and if you look at everything to the left of the line, it shows that a lot of times cotton is a very rewarding plant, that sometimes it will yield more at 65 or 75% of ET than what it will at 100% of ET. And then the red dot shows really what happens in the year of a drought, when we only received about an inch or two of water during the whole growing season, or practically the whole year. It really showed that definitely we live in an area where we cannot meet the crop demands without additional rainfall. So the purpose of the project is to try to help more producers move towards the left of the line. So let's look at crop evaporation in long-term averages from 1997 to 2001. And as you see, the majority of the crops have the highest evaporation from about July through about August. So we do have a problem. We also saw earlier that our soils do not necessarily have the holding capacity. So we look at how we can change that crop transpiration up. One of the things we looked at is just one crop, different planting times. And if we look at those, I know it looks busy, but just the difference in the planting time of that crop can change the amount of water that crop will use over time. Probably one of the biggest changes that we have seen in the program that producers has adopted and has used, they've adopted a lot of water practices, but one of the things is they're managing residue. There's been some in the area that have tried cover crops. Cover crops, you use a lot of water because about the time they're ready to terminate, they're using a lot of water, which we don't really have to use. So we've used stalk pullers and strip till plows and coulter rigs. And the end result is we want to plant a crop in as much residue as we possibly can, because the residue, when it covers up the soil, it protects that soil from evaporation. What has occurred in the last several years, though, is we've got another problem. We have Roundup-resistant careless weed or pigweed. And so that creates a lot of problems with residue management. Now let's look at LIPA versus spray. Does it matter? Yes, it does. This shows that we put some probes in two separate, the LISA and the LIPA. And this was in 2011, and we monitored this very closely. And if you look at the lines of the water penetration into the soil is not near as long on the left as what it is on the right. So what that's telling us, we was not getting enough water into the soil, and so it was stressing. And on this was a field of mine, and what we was using is I was applying 1.5 inches at a time, and we was coming back in about every 6 days, and that was meeting the crop water use. So let's look at, we had 3 years of data, so we finally compiled all this and did some economic data. Just telling a producer that there's 150 pounds difference in yield was not enough. He did not get the message. But as soon as we started telling him how much money that was, it changed the perspective. If we look at just these two deals, we can see that there's over $100 an acre just by one practice to change from a 65% spray of efficiency to a 95% efficiency. And so it equated to a lot of dollars. So the purpose of the whole project is to maximize water use, efficiency, and profitability. That's the goal of production agriculture. Now I want to thank you. So that's our project, and if there's any questions, I'd be more than happy to entertain any questions. Yes?
Great job. I love it. First, as a producer. But my question is, do you ask the producers? We across the state, we ask those same 11 guys that've been in ours for 5 years. to sit up there in a panel and have a summer summit that they talk about the challenges, they talk about the good things, and that exchange from the Water Balance Alliance, it's been phenomenal. It has made more inroads in adoption and even consideration than anything else we had tried. Do you do something similar, I assume?
We do. I mean, I'm asked quite often to serve on panels and that kind of stuff, and we do have producers that do that. And so, yes, that does help. It does seem to help. A lot of times I have been on some of those producers, and I probably learn more than what somebody's learning from me, just because of the exchange of ideas. One of the things I will share with this, what probably makes this program probably real unique, and I don't know about yours, but the producer does not receive any monetary dollars for keeping up with that. We have producers who feel very, very dear to water conservation, and what we've done is all the equipment that we have installed, it is theirs at the end of the project. One of the things that's probably really interesting, and it's even included on my side, is a lot of the producers, once we started monitoring the pivots, and when we went to net irrigate, when we started monitoring those pivots, they saw benefit from it, not only from a smartphone benefit of seeing what the pivot was doing, but they installed that on the rest of their operation. And we've also seen the same thing with using probes. You know, there's not a silver bullet when it comes to water management, and you probably know that. And it's sometimes it's pretty complicated, but we use the Smartfield technology, the AquaCheck probes, we used all those. We used ET programs, which is all very good, but ET is probably the most accurate in our area to calculate what water is being used. And the only thing they do is they just reinforce that ET number for us. If not, that's, yes.
Are you looking at the potential of increasing soil salinity with more efficient irrigation systems because maybe the salts are not able to be reached below the root zone?
Most of the time the salt in our area is not that much of a problem. I mean, we don't have that much of a problem with salinity. Probably the biggest problem we'll have is the lack of rainfall. We only receive about 10 inches of rainfall through the growing season, and since 2011, that's been very, very sporadic. I mean, it's been less than that. So probably the main problem that we have is from an irrigator standpoint is we have center pivots that at one point in time, you know, pumped 750 gallons a minute. Now they're pumping 300, 400 gallons a minute. You talk about the cost of production, the cost of it pumping. Our cost for pumping, was we used all small subs and stuff, our cost can run anywhere from $10 to $15 per acre inch. So there is a reason for us not only to conserve water, but to save water to save input cost, which can be very expensive in a hurry. Yes.
In your study area, have you had any issues with producers going down as a water tech? You made statements about 25% of saturated thickness in the study area. You have folks going down trying to get some of that water from deeper formations then you could maybe have some of those salinity issues after mixing. I just wondered if any of that was
We have not had any producers that go into it's in our area, it's called the Santa Rosa. Right in our area, on the project area, most of the time the Santa Rosa is very, very high in salt. So we've stayed in the Ogallala. There are parts of the area in the high plains and in Texas where the Santa Rosa is fairly good, but they do have to use other irrigation, the Ogallala, to help dilute it to keep the salinity down. Yes, I think in our project, we are seeing trends that farmers are cutting back. You know, it's minute. The main thing that what we've really seen is producers, a lot of the producers, the high-end water users, they have become more educated at saying, you know, I'll give you a very good example. We looked at several different producers like corn. It figures about 6 gallons per acre per minute to produce corn through the whole growing season. And so there's a producer that's in the project was visiting with me one day, and I was visiting with Rick and telling him this, but his idea was, well, I only have enough water to plant about 80 acres of corn on this pivot. This is what shows me, he's a food corn grower, and he says, this is about all the acres I can produce. He says, what am I going to do with the rest of them? Or how do I tell my landlord that I'm only going to plant 80 acres? And I says, I think you've already answered your question on how much water you have available. So yes, I do believe that we are gaining inroads rather fast, because at the cost of production, at the cost of pumping, and the water availability is all adding up together. So, yes.
You may be familiar with Nebraska's natural resources districts and their relationship with water allocation for farmers and so on. What do you have in Texas that regulates the allocation, regulates the amount of irrigation that we draw water? And give us a little, give me a little bit of an idea as to the relationship producers have with that regulatory entity or entities.
Well, we do have the water districts, and probably since 1990, in the late 90s, there has been quite a bit of legislation that has probably enhanced some of the water districts. And so the water district that we're involved with has just become up with starting to hand down restrictions on how much water we're allowed to pump. And we have the 50-50 rule of desired future conditions of the aquifer. And when we look at actually with the 50-50 rule is fairly close to the natural decline of the aquifer. So, you know, with all the water districts in the panhandle of Texas, we're just now starting to get into quite a bit of regulation with them. And there has been some opposition. The producers have been opposed to some of them, but the majority of them have said, you know, just give us the rules, give us time to get those adjusted, and we'll accept those rules. And that's really what has come about with this project is that we have starting to get a lot more information because the data that we've collected is accountable. And it's not small plots, it's large farmers, and so we have a lot of water data that we've collected over the years that is very, very useful, as well as the economic data.
Thank you.
All right.
All right, let's thank Glenn again.